So I'm going to move on to next installing the AD8307 logarithmic amplifiers for the forward and reflected power. Now there are a couple of boards that come with the fast circuits kit, and here they are here. I've decided to make my own board for a couple of reasons. The first one is I couldn't find any 1206 size SMD resistors, and that's the size that's actually on this board here. So I needed to do that. I think the other thing too is, now if we just look closely at the board here, you'll notice that the trace is cut away between here. I believe this is for pins 6 and 7. I believe they should really be attached. They certainly are on the circuit diagram here. So anyway, and the other thing too is I kind of wanted just one board for this rather than have the two separate boards. If we actually just pan over to where that gets installed in the box itself, it's right here on the back. So I've just bored a couple of holes here at the right distance apart. That'll slide in like so. And there's a couple of nuts that will go on the end of that to secure it. And then obviously, as we get these components installed, then here's the output, here's ground, here's 5 volts, and that all goes onto the board. So anyway, that's what I'm gonna do next. And these are SMD components with the exception of an inductor, and normally I just solder them in, but I did get another toy the other day, and it's this quick 861 DW SMD rework system. So let me just move that so you can actually see it. And this has been reviewed in quite a few places on YouTube, and so I think I'll have a go at doing that, and I'll record my results, and you can perhaps laugh at them. I'm better at soldering than I am using a hot air gun, so we'll see how that all goes. I've been doing it a bit of practice for that, but still yet to perfect it. So what I'll do is I'll get all those components on the board, and we'll move to the next stage of testing it. So that's that done, and I've tested continuity from the IC, and it's pretty hard to see, but there's the dot in the bottom left-hand corner of the IC there, and that's pin 1 and pin 1 at the bottom left there. So these ICs are pretty hard to see. You got to get it in the right light so you can see the dot quite clearly there. So anyway, next up is kind of connecting. So this is the ground, obviously. This is the output from pin 4, and then this is 5 volts, and there's a 100 microhenry conductor that goes inductor that goes across here. Keeps the RF out of the power supply. So I'll put the inductor in, and then we'll hook the power up here and get something so we can probe the output here, and then I can hook this up to my signal generator and see what we get. Okay, so here's the test setup here. I'm just panning up to the signal generator. I'm injecting a 7 megahertz signal. What I'm going to do is I'm going to start at minus 60 dBm and work my way up to 0 dBm and 10 dBm increments, and I'll probe the output in volts, and we'll measure it to confirm what's going on. So let me just start at minus 60 dBm here. So excuse the hands in the way here, but let me probe there. And you can see there minus 60 dBm is an output of 0.074 volts. So let me write that down. Let's go to minus 50 dBm. And we are now at 0.98 of a volt. Minus 40 dBm. .22. Minus 30 dBm. 1.48. Let's go to minus 20 dBm. 1.73. Minus 10. 1.97. And then finally 0 dBm. 2.22. So you can see there and it is rough. I mean, obviously there's going to be some inaccuracies just because of the way I'm measuring it, but every 10 dBm, let me just pan over to the results here. So every 10 dBm represents approximately a 0.24 volt increase. It does vary, so you can see there between minus 40 and minus 30, that's actually 0.28. But then again, between minus 20 and minus 10, we're back to that 0.24 volts. So obviously there's going to be a lot of inaccuracies introduced the way I'm measuring it, but that does confirm that the AD8307 is indeed outputting that expected voltage. I did try it all the way up to 15 dBm, which is the supposed maximum for this. And it did work also. It was around about 2.48 volts. So that's showing exactly what we expect between 0 and 2.5 volts for that for that range. Now, obviously, with a maximum of 15 dBm, that's why I mean that's part of the attenuation is going to come from the directional coupler. But in order to measure larger signals, we would need additional attenuation even on top of the directional coupler itself. But anyway, I will install the other side for the reflected power. I won't video that. It's kind of a repeat of what we've just done. and we will we'll come back and we'll take it from there.